All right. Good morning. There were a couple questions from page 116 from 2.3. So I'm going to do these first for the lesson. The instructions, which are on the previous page, say identify the values of the variables for which each radical is defined and then simplify. So first I got to say what values they can be. The only m, excuse me, the only m underneath the root sign is over here, and it's to the power of 4. It's an even root, so we're good. M can be anything, because if it's negative, it'll just cancel out, right? The n, on the other hand, cannot. If the n is negative, everything goes poorly. N is greater than or equal to 0. Okay? And then we got to just kind of factor and simplify. 28 is 2 times 14, which is 2 times 7. So 28, the root of 28 is going to be 2 root 7. So I'm going to leave a space for the m, 2 root 7. That m, the root of m4, is m squared. N stays behind. So we have 2m squared root 7n plus 63 is 7 times 9. Yeah, that's right. And then 9 is 3 times 3. There's our pair. We're going to pull that 3 out. There's already an m squared out. That n's not going anywhere because it's by itself. Now, that's it. If we wanted to add these, because it's saying add, we have the m squareds, it's great. We have the n's, that's great. But we have that 7n. So we cannot combine those. Just take a quick little check. What? I'm going to pause this because that's contrary to my brain right now. Yeah, that's weird. Back of the book is wrong. I thought when I see stuff like that, I'm not just going to rely on my own understanding. And in this case, oh my goodness. I was like, you cannot combine these. You cannot combine these. I forgot to put the 7 in. Now you can. Sorry. I just did this kind of a quick like search. They have to be identical. Well, they are. M squared root 7n, m squared root 7n. Sorry about that. 5m squared root 7n. There you go. I thought that's not possible. That's just because I made a mistake. Forgot to bring the 7 up. That's what happens when like the first thing I do upon getting on a bit. Let's come down here and answer math questions. 8C. Sorry, there's a fan on and it's bugging me. Be right back. I don't know what that sounds like to you guys, but it's distracting to me. Okay, 8C. Well, it's a big one. 5e root 24e cubed minus 7 times the root of 54e to the 5. Excuse me, plus e squared times the root of 6e plus 6e. Simplify. So we're just kind of adding and subtracting here. All right. They're all square roots. Yes. So these odd ones is going to leave one behind. It's going to leave one behind. It's going to leave one behind. Maybe they're trying to get them. Well, this isn't going to combine with any of these because it's just 6e. All of these are going to have a root left behind. So this bad boy is just going to stay by itself. Whenever you bring something out, you got to multiply it by whatever's already out there. Remember that. 24 is 2 times 12, 2 times 6, 2 times 3. So we're going to take out a 2. 6 is going to stay behind. So we take out that 2. 2 times 5 is 10. 2 times 5 is 10. And then e cubed, I can take an e out. E times e is e squared. What's staying inside is the 6 and an e. And I made this way too long. Does that make sense? E cubed, because that's just e times e times e. Take out the pair. E stays behind. Minus, I really wish I didn't do this. Minus 54 is, what's 54? 9 times 6. What's another way of doing that? 2 times 27. 3 times 9. 3 times 3. Pair of 3's, 6 stays inside. 3 times 7 is 21. E to the 5, I'm taking out e squared. Because e squared times e squared is e to the 4. E to the 4 times e to the 1 is e5. The 1e stays in there. With, surprise, surprise, 6. 6e, 6e, e squared, e squared. These two can be combined. So can this. There's nothing to do there. Did I write that one down wrong? Yep. Plus e squared root 6e plus 6e. All right, this one's more straightforward than I was thinking it might be. E squared root 6e, e squared root 6e, e squared root 6e. Those can all be combined. This one can't. There's no root sign and no e squared. So 10 minus 21, negative 11 plus 1 is negative 10. So that equals negative 10 e squared root 6e plus 6e. Now I might flip these around so it's just 6e minus, because I just like leading with a positive. But that's what I would get. Check my work again, make sure I'm not making another mistake. No. Perfect. Perfect. One more. 8D. Are you up for it? One more. Hello, voice. 8D. Good grief, Charlie Brown. Cube root of 16v to the 5. Cube root 16v plus cube root of 3w to the 4. So it's a v, that's a w, yep. Plus 2w cube root 24w. Is this all on the screen? Yep. Minus 5v cube root 54v squared v and w element reals. All right. So we're just going to simplify. I'm going to be able to fit this all on one page. Or one line, I guess is what I want. 16. I don't need to break that up, do I? The root of 16 is 4. So this one is going to become 4. And we could take out v squared out of this. Cube root. All the numbers are gone. There's a v left in there. Does that make sense? The root of v, if the root of v to the 4 would be v squared, but there's an extra one that's hanging around, so that stays in there. And this right here is an ugly v. Plus 3w to the 4, my marker, I'm having trouble reading that. Yeah, it's 3w to the 4. That 3 is not going, oh, this is cube roots. Cube roots. Cube roots. 2 times 8, 2 times 4, 2 times 2. Cube roots. That's different. So the v's, for what it's worth, that would be like v times v times v times v times v. So 3 are going to come out, 2 staying behind. So we have 2 v cube root 2 v squared. That's what that is. Sorry, missed the cube root for a second. Somebody must have screamed when they were watching this in the future. W to the 4. 3 of those W's, 1 comes out representing them, 1 stays in behind. The 3 stays. Plus W cube root 3W. Plus, obviously questions like this, there are going to be a lot of mistakes easily. That W is going to stay, right? There's nothing it can do. 24, we got to figure this out. 2 times 12, 2 times 6, 2 times 3. Cube root, groups of 3. 2's coming out. W staying. 2 times 2 is 4. So plus 4W cube root. 3 stays with the W. Yeah, W was there. Yep. Okay. 54. What? 2 times 27. 2 times 3 times 9. 3 times 3. So we have a group of 3's. 2 stays behind. 3 comes out. 3 times 5 is 15. There's a V there. Is that V squared? I'm just checking the book because I can't totally read it. That's V squared, so that stays because it's a cube root. I just about pulled it out. So 15, so there's already a V there, right? 3 times 5 is 15. The V is already there. Cube root. What's left behind? 2V squared. Isn't that convenient? Just because I can see this is negative, I'm going to start with the W's because I want to leave with a positive. It doesn't matter. 1W and 4W is 5W. 5W cube root 3W. And then negative 15 plus 2 is negative 13V, right? Because it's just a V, cube root of 2V squared. The insides have to be exactly the same, like we kind of were reminded with the last question that I just screwed up on. Well, I did, but I figured it out. 2V squared. There's your answer. But allow me to check. Number's at 8D. Negative 13V. 5W cube root 3W. Yes. Yes. Hopefully that makes sense. I keep thinking, I'm taking it way too fast, but I guess you can just pause it. Today's lesson, boys and girls, I agonized a bit over this. Got a secret to tell you. Agonized. This is what we did yesterday, right? So this is where we at. Sorry, I'm just looking at something here. So we have 2 lessons left. Pause that, copy it down, then I'll talk. Okay, good. Done talking, or copying, or both. I'm not done talking. Never. Couple things. Number 1, this is 2.4. After this is 2.5. After this, we're done for the week. And we're done for the unit. So I'm thinking probably next Thursday, I think, is when we do the kind of, that'll be our due date for our test or what have you. But also what I wanted to mention is, I just realized something. Oh, it's got 2 sides. That's what I thought. Okay, all right. Anyways, my little bit of agony about, I appreciate, respect, honor that you guys are wanting like questions done from the assignment. But I look at these, and for the kind of examples that are given, because I think some of the examples are harder and they cover the harder end of things. And if I was going to do a question instead of one of those examples, then it leaves you almost no practice. So I'm sorry, I'm going to do the practice. The good thing about this, you can skip ahead. Oh, makes sense? Okay, skip ahead. Makes sense? Okay, skip ahead. Because some of this will be kind of review-ish. I'm doing this with my hand for some reason, and all I'm seeing is this. So yeah, we're going to do all the examples, and that's something I promised. I don't know if I promised it, but I said I was going to do was all the examples just to kind of cover our bases, because again, you can skip if you need. Anyways, as long as the index is the same, we can multiply the radicands. The index is that little dude. Okay, as long as that's the same, we can multiply whatever's inside and whatever's outside. That's the one thing that matters. I can't multiply a square root by a cube root. It don't work, brothers and sisters. Rationalize the denominator. We talked about that previously. See, if I would have done this in order, it would have been smoother. That's also why I never took marks off. I just kept pointing it out when people would do it, because here this is where we kind of learn how to do it. Granted, I know you've done this in previous years, so anyways, blah, blah, blah. We're going to do that, so that should be pretty straightforward. Never want to leave a final answer with a radical in the denominator, okay? Moving forward after this, now you got no excuse. Okay. This is still 2.4, part B, if you will. This is the trickiest thing that we're going to do. I think the other stuff is pretty straightforward, and this isn't that tricky. Yeah. Okay, got it down. Good. But this is what this is about, and we'll get to it when we get into check your understanding number 4. This is a way to get the radicals out of the denominator when you've got something like let's say x over root 2 minus root 3. You can't just multiply this by root 2. It won't work. You can't just multiply by root 3. What it's saying, pre-teaching here, is you have to multiply it by the conjugate, which is root 2 plus root 3. Root 2 plus root 3. So what I've got in the brackets right here, this is 1, right? When something's divided by itself, it's 1, unless it's 0. But this will get rid of these radicals the very similar way that we would when we're come on, difference of squares, when we're doing difference of squares. Yeah, you'll see it. You'll see it. It's enough chit chat for me. We'll see it. Let me put this way. Okay, I'll pause this while I set up my notes or whatever. Alrighty. This is CYU numero uno, part A. 4 root 2 plus 2 root 5, in brackets, times 3 root 2 minus root 5. We do this the same way we do FOIL. First, outside, inside, last. Okay? We just multiply them, and then we collect like terms at the end. 4 root 2 times 3 root 2 is going to be 12 root 4. Multiply the outsides, multiply the insides, basically. Okay? 4 root 2 times... excuse me. Oh, I feel like I swallowed something gross. 4 root 2 times negative root 5 is going to be negative 4 root 10. Positive and positive here. 2 times 3 is 6. See, 2 times 3 is 6. Root 5 times root 2 is root 10. And then plus times negative, so that's negative 2 times 1 is 2. Root 5 times root 5 is root 25. If you're still thinking a little bit about how I was talking about multiplying a conjugate, clearing things out, you'll see, root 5 times root 5, that root sign is going to go away. This root sign is going to go away. Kind of tells you a bit how to do it. But because this isn't difference of squares, these middle ones don't cancel. Anyways, simplify. 12, the root of 4 is 2. 12 times 2, 24. These are both root 10. We have negative 4 and positive 6, so it's going to be plus 2 root 10. And at the end here, the root of 25 is 5. Negative 2 times 5, negative 10. One more step. 24 minus 10 is 14, plus 2 root 10. You dig? If this is grievous for you and you want me to go slower, you want me to explain more, please, please, please say so. For those of you that it's like, no, yeah, no, this is easy. Good. Skip ahead a little bit. Next one, B, 4 root 2. Because I'm doing all of them. 4 root 2 plus 2 root 3. Uh, 4 root 2 minus 2 root 3. 4 root 2 minus 2 root 3. All right. Oh, look at this. Beautiful. These are the conjugates of each other. They're exactly the same, except the middle sign is different. So this is a difference of squares question right here, which means these two are going to cancel out. I'm going to do it all just so you see it. But it's the first and the last that are going to matter. Anyways, 4 root 2 times 4 root 2 is 16 root 4. 2 root 3 times 4 root 2 is 8 root 6. Remember, if the insides are different, you can multiply them, but you can't if the index is different. If this was cube root 3, square root 2, you can't multiply them. They would just be right next to each other, kind of the way an x and a y would be. Oh, I did it in the wrong order. Let me erase that because I did it in the wrong order. First should be outside. Sorry about that. Okay, so that's negative 8 root 6. Sorry, guys. Now over here, it's 8 root 6. I just want to do it the way I said I was going to do it. First, outside, inside, last. First, outside, inside, last. So last now, 2 times negative 2 is negative 4. Root 9. Watch, this is going to get rid of all root signs. The root of 4 is 2. 16 times 2 is 32. This can't be simplified, neither can this, but we can add them together. Negative 8, positive 8 is 0. 0 root 6, this is 0. We don't got to write anything down. If you want to write 0 root 6 or 0, do it. I'm not going to. The root of 9 is 3. 4 times 3 is 12. Minus, because it's a minus. 4 times 3 is minus 12. So this whole thing equals 20. This right here equals 20. That's how they end up canceling each other out. It's kind of beautiful. All right. Okay. I was just glancing at numero dos. I'm just going to maybe turn this around. So CYU2, page 122. Let's start with A. This is what happens. You're talking to yourself all day. Okay, so it says identify the values for the variables for which each expression is defined and then simplify. So first one is 7 plus 2 root b. The whole point of this is to show it works with variables too. 3 minus 5 root b. B has to be what? What? Yes, greater than or equal to 0. It's an odd power, b to the 1, and it's in a square root. Can't be negative. It's negative 1. It all goes poorly for everyone. 7 times 3, 21. 7 times negative 5 root b. That is negative 35 root b. You kind of multiply what you can. And if you're thinking, well, wait, the radicals have to be exactly the same. You can think of this 7. You can think of it as 7 root 1. Root 1 times root b is root b. First, outside, inside, 2 times 3 is 6. And then minus 10 root b. Well, we've got a bunch of root b's, so those can all combine. 21 can't. 21, so root b, root b, root b. So negative 35 and 6 is negative 29 and 10 is negative 39. Minus 39 root b. Oh my goodness. I just checked my answer. It's wrong. You know why? Because look at this. 7 times 3 is 21. 7 times negative 5 is negative 35 root b. 2 root b times 3, 6 root b. 2 root b times 5 root b. The root b's. B squared. Sorry about that. These are the only like terms. Sorry about that. So let's simplify a bit. 21. Negative 35 plus 6 is negative 29. Root b. B squared, so b comes out minus 10b. Oopsie, you drop your guard for 1 second and you make mistakes. Sorry about that. Everybody see what I forgot to do? Root b times root b would be root b squared. Okay. That's A. Let's look at B. It's good for me to make mistakes because then, this is me convincing myself by the way, because then you can see, oh, I got to be careful not to do that like he did, and then I'll be smarter than him. And it's true. B, 3 root x plus root y, I'm really mixing it up here, times 3 root x minus root y. Oh, there's another difference of squares here, my friends. But then we've got, oh, we got something else in here that's craziness. Minus root of x plus 5 root y squared. Okay, first thing to note, this will need to be expanded. I didn't want to rewrite it all out just because there wasn't room right there. This right here, my friends, is a difference of squares. Can you see that? So really, all I need to do is multiply these guys and then multiply these guys, because the middle ones will cancel. And I'll tell you why right now. So here's like the outside and inside, they cancel. This is negative 3 root xy, positive 3 root xy. They cancel. So I'm just going to do the first and the last. So that is 9 root x squared. And if you have a problem with this and you want me to kind of do the whole shoot match, please let me know and I will. Hopefully you're getting your difference of squares down. Minus the root of y squared. So let's kind of pause that. Now let's deal with this a little bit. I'll just expand it so we know what we're looking at. Root of x plus 5 root y times root of x plus 5 root y. This whole bracket set up here, like right here, this is squared. It doesn't mean this is squared and this is squared. It means this whole thing multiplies itself. Cha-ching, cha-ching. So that's how we got to write it out. Okay, next steps, I'm going to do a bit of simplifying here. X squared is x, so that's 9x. Minus y squared is y, so that's y. This stuff's done. Okay, all of this came to this, if I didn't screw up. Now this minus sign, that's going to change a bunch of signs. So what I'm going to do is I'm just going to leave it in brackets, just a big set of brackets, so I can deal with that later. Because if I try and do it now, I feel like I'm going to make a mistake. And it's always easier. Do what's in the brackets first. Okay, root of x times root of x squared. If you're doing this, like on your own, and you do root of x times root of x, you want to just write down x, I'm okay with that, as long as you have a good understanding and you don't, make too many mistakes with it. If you're comfortable with it, do it. Outside, root of x times 5 root y plus 5 root xy plus same thing right here, 5 root xy plus 25 root y squared. Let's keep going. 9x minus y minus, yeah, I'm going to drop the brackets. The root of x squared is x minus x. This negative, if it helps, just draw this or something so you remember. 5 root xy, that's 10 root xy, so it's minus 10 root xy, because we're just adding them, we're not multiplying them, minus 25, and the root of y squared is y. So we have some like terms to combine here. 9x minus x is 8x. Negative y minus 25y is minus 26y. And this poor fella has nobody to combine with. Well, that's an ugly answer, eh? 8x minus 26y minus 10 root xy. Yep. Oh, I forgot to talk about non-permissibles. In the very beginning, very first question, they're all just single powers in square roots. X comma y have to be greater than or equal to 0. If they're negative, it wrecks the world. Okay? Huh, you thought 2020 was crazy already? I got nothing. All right, moving on. Moving along, little doggies. Look at all these examples. Number 3. Oh, see? This stuff we've already kind of learned in a little bit of a casual way. So we have 5 root 7 plus 3. 5 root 7 plus 3 over root 7. And what the book is asking us to do, it looks like this marker is drying up, hey? It doesn't take long. It's saying simplify, which means, if you can't see kind of, well, what the heck am I supposed to do? Get rid of the radical in the bottom. Get rid of the radical in the bottom. So as we've been taught and as we've been doing, multiply the top and the bottom by the same thing. I don't know what the black looks like. 5 root 7 times root 7, excuse me, is 5 root 49. And then 3 times root 7 is 3 root 7. Root 7 times root 7 is root 49. Root of 49 is 7. 5 times 7 is 35. Plus 3 root 7. Root of 49 is 7. That's it. Now, if we could simplify, we would. Now, see, 7 and 35, these have a common factor, 7. 7 goes into this 5 times. But it does not have a common factor with 3. Okay, 3 divided by 7 is nothing good. So you can't simplify it. And that's a common problem I'm still seeing. When you factor, when you cancel, if there's one thing on the bottom and a few things on top, there has to be a common factor for the bottom and every single thing on top, whether it's one thing or 6 things. All right, now after all that yapping, I should check my answer and make sure I did it right. Yes, okay. B. 6 minus 2 root 6. 6 minus 2 root 6 over 3. Oh my word. Guess what I did? I just copied down the answer. Well, we know where we're going. I don't like this remote teaching, you guys. I need humans in front of me. Do you hear that squeak? Brought my office chair from home. And my cat is starting to scratch the crap out of it. Okay, so looking at this, there's a couple different things that we can do. Root of 18, we can simplify this first. Do some canceling, and then rationalize. Or we can just rationalize now, because it all works out the same as long as you follow your rules of math. Probably easier if you did it now. Like if you simplified this now, because that way, later on, we're doing root of 18 times root of 2, root of 18 times root of 3, and then you're going to have to kind of factor tree everything. Here, we just do the bottom one. Trying to decide, do you want to see it both ways? Yeah, you know what? Skip ahead. If this video is too long, skip ahead. I'm going to show you both ways just to be safe. Some of you just went, yes. Some of you are like, ugh. Welcome to the world. It's not about you. It's about your neighbor. All right. So root of 18, let's just look at that bad boy. So 18, 2 times 9, 3 times 3. So 18 is 3 root 2. So if we rewrite this, I'll try and hug the left page so I can go crazy on the right later. So this equals 6 root 2 minus 4 root 3 all over 3 root 2. I assumed, oh no, that's wrong. I need a break, or should I start drinking coffee? Good grief, Charlie Brown. That's 3 root 2. Take the 3 out, 2 comes in. I thought that we'd be able to cancel some things. We can't. But it's still simpler to multiply. Okay, so this equals 6 root 2 minus 4 root 3 all over 3 root 2 times 3 root 2 over 3 root 2. So 6 times 3 is 18. Root 4. Negative 4 times 3 is negative 12. Root 6 all over 9 root 4. Simplify. 18 times 2 is 36. Root 6 not going to simplify. It's 2 times 3 minus 12 root 6. 9 times 2 is 18. Now we're going to simplify. Common, I can't do 36 divided by 18 is 2, and then 12 divided by 18 is a third. Has to be the same for each. I'm glad we went this way. So what is the biggest number that goes into all of them? Is it 6? 6, 6, 6, 6. I had to say it 4 times just because it looks like 6 goes in. Anything bigger wouldn't go into 12 unless it was 12. 12 goes into 36, but not 18. So if I divide each of these by 6, 6 goes into this 6 times. 6 goes into this twice. 6 goes into this 3 times. Those are our numbers. 6 minus 2 root 6 over 3. I'm just wondering, is it worth showing the other way? I will. I'm going to show it quick. I know the answer is right because I wrote it down over here like a Goomba before. Straight. Okay. So if we want to go this way, it becomes 6 root 2 minus 4 root 3 all over root of 18 times root of 18 over root of 18. I still think this is probably the easier way, but anyway. So this equals 6 root 36. Oh, maybe not. Maybe it's just going to be easy. Minus 4, 3 times 18 is 6 times 9, so that's 54. All over the root of 18 squared, which is 18. Right? I'm not doing that because I don't know what 18 times 18 is. It's a big number. Simplify. Root of 36 is 6. 6 times 6 is 36. Minus, now 54 we got to deal with. 54, maybe a better question is, where are we going to deal with this? I'm just going to do it up here. 54 is 2 times 27, which is 3 times 9, which is 3 times 3. So 54 is 3 root 6. Okay, 54 is 3 root 6. 3 root 6, 3 times 4 is 12 root 6 all over 18. Notice we'll get to the same spot, so I don't need to continue. So really it's a matter of preference. You can do it both ways as long as you follow the rules. That was 3B. Good grief, Charlie Brown. We've got one more to do. This is 40 minutes and counting. But it also included some answers and stuff. So I don't know if it really counts. And tomorrow's Wednesday. Next week, the following week, No school Friday for students. There's for teachers. And then it's the long weekend. So that's good, hey? Why is this crooked? Last CYU. This one we're going to multiply by conjugates. CYU number 4. Because this is so long, I'm going to tell you something. Because this is so long, I'm not going to give you kind of an extra day. Like Thursday's going to be a new lesson, but Friday won't be. And Friday won't be the beginning of your project. Okay? Can you dig it? You'll get some time from me. All right. Okay. Number 4. 4. This is A. This is page 125. 4 plus 2 root 6. 4 plus 2 root 6 over 3 root 2 minus 4. All right. So if we're going to rationalize the denominator, we need to multiply it by its conjugate. If the only thing on the bottom here was 3 root 2, I could do 3 root 2 over 3 root 2. To be honest, I could just do root 2 over root 2. Which got to get rid of the roots, right? But it's more complicated here because there's 2 terms. So we got to say, like, what would make this thing, what would be the other half of this? Just the bottom, just ignore the top. What would make this be a difference of squares? What would we multiply this by? Well, it would be 3 root 2 plus 4. Remember in the beginning of the year, I was talking about difference of squares and that it should be kind of second nature. This is one of those reasons. I know it's hard to see, hard to trust, but it is. So now I'm just going to go to the next line. I'm going to do it in blue because I feel like being colorful. Because we got to do all this. We've got to foil our way through this. The top part's going to get probably pretty big. Bottom, not so much. 4 times 4, 16. 4 times 2 root 6 is 8 root 6. 2 root 6 times 4 is 8 root 6. Stop, 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 stop. Needs to be the same on the top and the bottom. I have no idea what, I guess I was talking too much. 3 root 2 plus 4. It should be the same on the top as the bottom. When I noticed it was starting to do this, I'm like, this looks like something was squared. Yeah, it should be the same top and bottom. Sorry if I confused you. Anytime you're going to kind of introduce something, it shouldn't change the overall number value. 3 root 2 plus 4 over 3 root 2 plus 4 is equal to 1. What I did before was just a brain cramp. I apologize. Today's a brain cramp day. I can tell. Okay, let's try this again. Sorry. 4 times 3 root 2 is 12 root 2. It's a good thing it's recorded. You can maybe see these things coming and pause it or something. 4 times 4 is 16. 2 root 6 times 3 root 2. 2 into 3 is 6. And root 6 times root 2, root 12. And then 2 root 6 times 4 is 8 root 6. Yeah. That's better because it looks like a dog's breakfast. Now the bottoms, I'm gonna do every step, but I'm not in the future. 3 root 2 times 3 root 2 is 9 root 4. And then 3 root 2 times 4 is 12 root 2. Negative 4 times 3 root 2 is negative 12 root 2. See, this is the stuff I'm not going to do because I know they just cancel in the future. So in the future, I'm not going to do this middle step. And then the last, negative 4 times 4 is negative 16. Okay? So let's simplify on the top. Let's see if we have like terms. Root 2, no root. Root's 12, root 6. 6 root 12. It's 2 root 3. It's not going to, nothing's going to be combinable. But I'm going to simplify this just so my top is done. 12 root 2 plus 16 plus this is 2 root 3, 2 times 6 is 12, plus 12 root 3 plus 8 root 6. Isn't that crazy looking? Oh, just put right in that space here. Now the bottom, root of 4 is 2, 2 times 9 is 18, plus 12 root 2 minus 12 root 2, those guys cancel, minus 16. So this whole thing's going to be over 2, which means you're going to be able to do some canceling. So equals, sorry I keep writing this, I said I would do every step. All over 2. My poor fading blue marker. So now this is 12, 16, 12, 8. They're all even. 2 goes into all of those. That's why I can cancel. That's why I can simplify. If just one of these was off, if this was an odd number, if just one of these was an odd number, just one of them, I'm done. Okay, I can't simplify. This would be done, but they're all even, so I can simplify a bit. So this 2 is going to get canceled. There's a 1 left behind, which means the fraction's over. 2 goes into 12 6 times, 2 goes into 16 8 times, 2 goes into 12 6 times, 2 goes into 8 4 times. Rewrite our final answer. 6 root 2 plus 8 plus 6 root 3 plus 4 root 6. Now, that looks... I'm going to have to get rid of this marker. That makes me sad. That looks like a mess. But... it's right. It's exactly right. So that's another little life lesson. If it looks crazy at the end, doesn't mean it's wrong. It'd be nice if everything canceled and your final answer was 3. But no, the world does not often work that way. Okay, you want one more example? One more example? Okay, now I'm starting to feel guilty saying I wasn't going to give you an extra day. I promise you, there'll be no new work assigned Friday. And if, I don't remember off the top of my head, if lesson 5 is ridiculous, if I seem to be spending all my day in front of a screen like this again, then I'll give you Monday as well. Okay, but let's just one day at a time it. 4B. Page 125. This is a CYU. 2 root 3 minus 4 root 6. Over 3 root 2 plus 2 root 3. All right, so our conjugate is 3 root 2 minus 2 root 3, right? Do you want this in a different color? So this is 3 root 2 minus 2 root 3 over 3 root 2 minus 2 root 3. Okay, the red's fading too. It's getting bored of black, but it's my freshest color. 2 root 3 times 3 root 2 is 6 root 6. 2 root 3 times negative 2 root 3 is negative 4 root 9. Negative 4 root 6 times positive 3 root 2 is negative 12 root 12. Negative times negative is positive. 4 root 6 times 2 root 3 is 8 root 18. Did they make it like this? 6 root 6, 12 root 12, 8 root 18. These are the mental games, eh? Like, is this one right? Second one? Yeah, it is. All right, so that's all the top. On the bottom, remember, I'm just doing the first and the last, because I know the other ones cancel. Had to do it all on the top. Bottom, I don't need to. 3 root 2 times 3 root 2 is 9 root 4. Minus 4 root 9. See, like what? 9 root 4, 4 root 9. Why are they doing this? Making me think too hard. Okay, so let's simplify a bit on the top. 6 root 6, that's not changing. Oh, is this on the screen? Yeah. 6 root 6 Root of 9 is 3. 4 times 3 is 12, so that's minus 12. 12 we can simplify. 12 is 2 times 6, which is 2 times 3. So 12 is 2 root 3. 2 times 12 is 24. Minus 24 root 3. See how I got that? From 12 root 12 to 24 root 3, because I was able to pull a 2 out. 2 multiplies that. 3 stays behind. Plus 8 root 18. 18 is 2 times 9, which is 3 times 3. So 18 is 3 root 2. 3 times 8 is 24. Root 2. Root 2, root 3, root 6. No root, can't combine anything on the top. 9 times 2 is 18. Minus 4 times 2 is 8. So that's going to be 10 on the bottom, which means we're going to be able to do some canceling. Is that right? 9 times 2 is 18. 4 times 2 is 12. Oh, good thing I checked. The root of 9 is 3. 4 times 3 is 12. It's going to be 6 on the bottom. Sorry about that. So you got to go slow and not talk to people while you're doing it. Breaks your concentration. 6 root 6 minus 12 minus 24 root 3 plus 24 root 2 all over 18 minus 12 is 6. 6 goes into each of these evenly. Nice. These just cancel. It's 1 for 1. 6 goes into 12 2 times. Goes into 24 4 times. Goes into 24 4 times. We rewrite and we should be done. Root of 6 minus 2 minus 4 root 3 plus 4 root 2. Almost afraid to check the answer. I made a mistake there. Where else did I make a mistake? And I got a different answer. The root of 4 is 2. 9 times, let's start here. 9 root 4, 9 root 4. Root of 4 is 2. 9 times 2 is 18. 4 root 9. So I got 4 root 9. Root 9 is 3. 4 times 3 is 12. 18 minus 12 is 6. I'm going to pause it, see if I can find my mistake without wasting your time. Oh my goodness, you guys. This is right. I went through every single step and then I checked the book. And you know what? You know what? I hate being a teacher saying, oh, the textbook's wrong. But in this case, you can see it clearly. You can see it clearly. Don't worry. You tell me, for 4b, are they done simplifying? Are those lowest terms? No. They went halfway for some strange reason. 3 is common to 3, 6, 12, and 12. So anyways, I'm right. The textbook's wrong. All right, hopefully that makes sense. Sorry that was so long. Peace, love, and egg rolls.